is it today? Wednesday? Do you know what day it is?
It is Wednesday. It feels it's the fifth day of the week.
It's been a big deal, been a big show. This is Andy Keane, and you're what, the general manager of?
I'm the general manager of the Tesla business.
Of the entire Tesla business.
Yes.
Very good. And it's been a busy show for you.
Oh, it's been crazy. We have partners, we have ISVs, we have scientists, we have a huge number of all people using the GPU, and they're all here, and they're all talking to each other, they're all trying to learn from each other.
It kind of has the feeling of a mini supercomputing show.
Right, and this is one of those shows where it's kind of the early days in a lot of the early shows, right? Where you had all this energy because everything's new, right?
Yeah.
Everyone is trying to tell people what they've done and all these great results, and kind of look what I did, and look at my work. And so that's what we're getting here, and we have people with this wonderful software and all this work, talking to people who are trying to put together systems, business, and tools, and the press are here in
big
very
deal.
large numbers. So it's really
and actually, I mean, a lot of the news has come out on the systems side, and that's the really interesting thing to me, is that these are now being packaged and productized and SKUized in the catalogs now.
Exactly. I would say one of the most dramatic changes from last year is the number of OEMs who now including the GPU just as a standard part of the server.
Yeah.
And actually at the show we had blade announcements, which if you kind of look at the work it takes and all of the kind of engineering it takes to do a blade system, it's really a remarkable advance. So the IBM Blade Center, kind of this standard in computing, right? It's been around for a large number of years.
Huge installed base out there, common cabinet for most of those generations. That's a big deal that you can now slot GPUs into a Blade Center.
Standard IBM Blade, and it fits into the Blade Center. So huge, and so that's one aspect of innovation, is going into this installed base, huge worldwide footprint. The reach and scale of IBM. It was really an amazing advance and a great announcement. We had 3 blade announcements at the show. So we had IBM, naturally. We had Cray, which announced a new blade into the XE6 chassis.
Okay.
Again,
but did they have a Tesla blade or not?
Not until this announcement.
Okay.
No, this was basically the first time they've talked about a blade in the XE6 cabinet. And there's currently a CPU version, and now they've kind of augmented that with a GPU blade as well.
So just GPUs on that blade?
No, they're actually a combination of CPUs and GPUs. Again, in our model, the CPUs and the GPUs are working together in a heterogeneous complementary model, right? So sequential processing and parallel processing on one blade. And now people have that option. They can mix and match. They can go kind of a pure heterogeneous system and kind of use the CPUs and GPUs where the application requires that type of processing. So big advance. I mean, Cray, what a name in supercomputing.
Oh yeah.
Right? Huge presence on the top 500, including most of, I forget the fact, 9 of top 3.
You can actually speak. The production values on this, I keep explaining it, you can actually say something.
9 of the top 30.
9 of the top 30.
Yeah. Hey, idiot.
Yeah. I'm going to go ahead. Yeah, there he is. Okay.
So you won't put the hey idiot part, right?
Yeah, actually that's in there. Yeah. Again, I'm editing on Lenovo's finest T61 tablet.
I'd like to introduce Andrew Humber.
Andrew Humber. Yeah, it's him. Sure.
I really appreciate that. Cray, very good presence on the top 500.
IBM's got a fairly good presence in HPC.
Some of the top 3 systems on the top 500 list. I mean, amazing. So we're now kind of in this HPC standard. We're now kind of global footprint. The third announcement that was made by a company called T Platforms, very, very strong HPC company in Russia. Right? So we hear less about it. Right? They're in our market, we hear certain names, but in Russia, T Platforms really has been synonymous.
I've heard they've got a really interesting heat design.
Yeah, so it's a very, very novel design. So it's a very thin blade. It has this monolithic heatsink that keeps the profile very, very small. Very, very high density in the cabinet, and they can actually cool between 50 and 75 kilowatts per rack. It's actually amazing. And they have a very large system installation at Moscow State University, and it's
not University of Moscow, Moscow State.
It's Moscow. It's MSU, right?
MSU.
It's Moscow State University. And so they have
good football team, by the way.
Good football team.
Yeah, Moscow State. Yeah,
I think I have the T-shirt.
Yeah.
So,
but I'll have to get over and take a look at that. It's here, right?
Yes, the T platform.
Okay, I'll take a look
here
at it.
And
get a little film, maybe show that when we're talking.
The team is here. They can show you the blade design, and you can see some of the novel packaging.
Okay.
And how they actually kind of fit the GPU into such a small space. And so, really, one of the advantages is that you now have a very small footprint data center. You can pack an incredible amount of computing horsepower in that very small space. But
you know, the big thing that keeps resonating with me is I'm always looking at the intersection of enterprise and HPC.
Yes.
And being in the catalogs, being in the SKUs, being in the blade chassis. That's a nice entree into enterprise.
Absolutely. And you start to look at a lot of the applications that are here.
Mm-hmm.
We're seeing applications outside science, right?
Mm-hmm.
Very strong presence in science, but we're starting to see work in data analytics, in machine vision.
I think analytics is going to be huge.
Huge. And so all of these other places. And so where we're trying to put the Tesla products and kind of partner with people is when these applications start to develop, when that buyer goes, okay, I need to deploy GPUs, we're in the type of systems that they deploy today.
Yeah.
In many cases,
it's not an exotic animal anymore.
Exactly.
It's not a science project or experiment.
So when the OEM comes in, when that system maker comes in, and they say, how am I going to put GPUs in the data center? They have a well-packaged solution. It's kind of this frictionless sale right into the deployment from the customer.
Using my well-developed stream of consciousness approach to interviewing,
yes.
I've got a quick question. One of the things I've been thinking about is as this advances into enterprise, to me, what makes sense is if GPUs can be a shared resource among a lot of systems. Is that something that makes sense with you?
So,
because utilization is going to be key.
System or
GPU
as
a grid member.
Yes. So there are already grid deployments that use GPUs. Again, our goal in the GPU and how we actually integrate the GPU into systems is we become part of the system. So the current infrastructure for if you have a grid system, for instance, how the grid views that node, we actually fit like a computer node. So you can
That's what I'm thinking.
Include a GPU deployed as a grid node.
And you've got an x86 processor there to handle the
exactly
to feed it.
Exactly.
But it's network attached compute.
Exactly. So that's an example of their deployments currently out. Finance, the
financial
market
financial
in particular is very wide user of grid style systems, and we already have deployments where people are using that type of technology. You look at the other side on cloud, and there is a lot of interest, and there's actually work in the cloud that's going on with GPUs. Why is that going to happen? Well, people want to flexibly provision, right? They have a little bit of GPU, and they kind of need a little more for scale up or
for mobile.
They
too.
Have it for concept.
That was one of the demos.
Exactly.
That you've got a laptop and you can at a client location manipulate something and have it.
And it's really capability as a service, right? Which is what we were looking at with iRay and Reality Server, where you could put ray tracing in the cloud, right? So it's a part of the workflow, but it's incredibly compute intensive. So the cloud is actually in some of the early applications we're seeing is where, the local client for design and for what you're normally doing is fine, but now you want to do that final render or you want to do that final simulation. Well, that workstation doesn't have enough horsepower, or you want to scale up to a large simulation. Well, you
do
push
it
a button,
quickly.
put that all from the cloud, right?
Yeah.
And then it comes back as a result. And that's what you saw at the keynote, right? You
great.
saw an example where, I could do my design on that notebook and then press a button and have that render be done in the cloud. So, again, it's the whole way we're trying to deploy Tesla is it's from the consumer side. It's from the person who's using the computer. How are they using it? Right? Are they using a cloud? Are they using an internal cluster? Are they using a workstation? And then you want to partner with people who are designing the workstation, designing the cloud, designing that cluster. And that's the solution. And then they're actually actively pitching that to that customer. That's the way you have to design this business. It's not, it's not a graphics board. It's not a computing board. Right?
No.
It's not a piece. It's part of something that a
solution.
customer has to use. Yes,
that's what we're getting to.
Exactly.
Great stuff. Well, thank you very much, and have a great show.
Excellent.
Good stuff. Talk to you later.
Okay.
Bye.